Welcome to a new WavePart review video. Today we're going to take a look at NETGEAR's M4250, a brand new line of audio-video tailored Ethernet switches. I will start with an overview of NETGEAR's AV switches and how the M4250 fits in. Then it's time for my first test. Does the switch work out of the box with Crestron NVX? There are two ways of configuring the switch using a graphical user interface. The classic web interface and a new ProAV GUI. I will show both of them. Next, I'm doing a quick test with Dante Audio over IP where I use the ProAV GUI to configure the switch. IGMP Plus is NETGEAR's addition to IGMP. What is this and is it of any use? Last but not least, my verdict. In 2016, NETGEAR introduced the M4300 series switches tailored for demanding AV over IP applications. Although there are 1 gigabit versions available, the focus is on 10 gigabit endpoints. When I say endpoints, I mean AV encoders or decoders. SDVoE is probably the most widely used example of 10 gigabit endpoints. The M4500 line was introduced in 2019 to function mainly as core or spine switch with speeds up to 100 gigabits per second. So what's the difference between the new M4250 and the existing M4300? First of all, the M4250 is not designed for 10 gigabit endpoints. And although it's a layer 3 switch, it does not support the OSPF routing protocol. And last, it does not support stacking, the process where you group multiple switches to one single virtual switch. Now that we've seen the features that the M4250 does not have, let's now focus on the features it has. First of all, the line is more affordable than the M4300. There are different models available with 1G endpoints, 2.5G multi-gig endpoints, and 1G and 10G fiber uplink ports. There's a 16-port 10G fiber core switcher available, and depending on the model, it supports PoE Plus and even PoE++, the 90-watt version of PoE. There's an optional AVB license, the NETGEAR proprietary IGMP Plus function, and a new ProAV user interface. Now it's time to zoom in on the M4250 12M2XF, the one I'm using for this review. So here's the front panel with a USB connection for USB storage devices, a USB-C connection that's for OEM purposes, an M10 threaded hole for mounting, as well as a VESA connection on the bottom side of the switch. We have port activity LEDs, a power and a fan LED on the front of the switch, and also a power and a fan LED on the back side of the switch. An out-of-band port, we'll discuss that later. A console and USB-C port if you want to configure the switch using the command line interface. Then we have the 12 multi-gig ports, 2.5 gigabits per second. 2 SFP Plus connections, 10 gigabits per second. Mains connection, including a mains switch. And the M4250 comes with standard 19-inch brackets as well as recessed versions that allow cabling. The 19-inch brackets can also be mounted on the other side of the switch so you can decide what's front and back. The AV over IP solution I'm going to use for my NETGEAR test is the Crestron NVX-350, which is a 1 gigabit AV over IP solution that has a low compression and low latency. It uses multicast. The default stream is 750 megabits per second, and the units can be configured both as encoder and decoder. My first test is if the NETGEAR M4250 out of the box, so without any configuring, will work with Crestron NVX. So here's my setup. We have the NETGEAR switch, 2 Crestron NVX-350s configured as encoders, and 2 350s configured as decoders. They're all connected to the switch. And then we have a laptop for configuring, connected to the 5th port of the switch. We have 2 sources, one BrightSign player and one Google Chrome, connected through HDMI to the encoders, and we have 2 displays connected to the decoders. So this is what the setup looks like in real life. We have the two encoders on the left, we have the switch and the laptop in the middle, and the two decoders and displays on the right. In the previous setup video, everything was configured, the Crestrons and the NETGEAR switch, and what I'm going to do now is reset the switch to out of the box settings and see what happens. I increased the speed of the video. It takes about a minute or so for the switch to reboot, and as you can see, the video is coming back and everything's working fine. It seems like everything is working fine out of the box. Please note that we are working with high bandwidth multicast streams, 750 megabits per second, that should only end up where they are needed. In this case, it means that the laptop should not be flooded with these streams. What you can do is go to the configuration of the switch and inspect the multicast table to see that everything is fine, but there's another simple check you can do. If you check the port activity LEDs, you will see the following. The LEDs on port 1 to 4 are blinking very fast. They are connected to the Crestron NVX, and port 5 connected to the laptop is very quiet. Exactly what we want. Now that we know that the M4250 works out of the box, let's look at the classic web interface for configuring. The most obvious thing to do is just connect the laptop to port 1 of the switch for configuring, but there's a better way. The most left port of the switch is called the out-of-band port. This port is completely isolated from all other ports of the switch, and that means that there's no possibility of video flooding to this port from one of the other ports. There's no chance of locking yourself out of the switch, and if you change the IP address of the switch, you will not have to reconnect your laptop because it's connected to the out-of-band port. The out-of-band port works both with DHCP or fixed IP. And in practice, this means that if you take a switch out of the box, connect the out-of-band port to any existing network with a DHCP server, just find out the IP address of the switch and you're ready to configure. So we're now connected to the classic interface of the M4250, the classic web interface. It's on port 80, the standard HTTP port. There's also an HTTPS connection if you want. This is the default IP address of the out-of-band port, and here we have all the information of the switch, including its IP address, management VLAN, MAC address, etc. All the information and the settings in the web interface are divided into tabs. We're now in the System tab, and in the System tab we can also go to Services to set our DHCP server or our SNMP settings for monitoring. In the Switching tab we can make VLANs and set our multicast properties, IGMP snooping being a very important setting. We can make link aggregations to combine multiple ports to a single connection. Routing, the M4250 is a layer 3 switch, which means it does routing. We can do static routing, but also RIP, RIP, and multicast PIM. Quality of service. In the security tab, we can set a radius server for extra security. Monitoring, we can do port mirroring and write log files. And in the maintenance tab, we can update firmware, but there's also possibility to export settings and import them again. Now that we've covered the classic web interface, let's take a look at the ProAV GUI and how to get there. To open the ProAV graphical user interface, we have to enter the IP address of the out-of-band port, only this time with :8080 added to it, to connect to port 8080 of the switch web server. Now we're in. We can see that ports 1 to 4 are active because they are connected to the Crestron NVXs. Here we have all our device details. There's one pre-configured profile called management VLAN with all 14 ports added to VLAN 1. We can see the CPU and memory utilization, and there's information about fans and temperatures. There are 3 fan modes available: off, quiet and cool. Default is quiet, but you can turn the fan off completely. Very nice if you want to put the switch on a desk, for instance. There are several network profiles, including Dante, QSys, AES67, audio video bridging available, and you can create your own profiles as well. Link aggregation, we can bind multiple interfaces to one single virtual interface for switch interconnection. We can do firmware upgrades and a factory default. And there's an optional AVB license available for the M4250. Now let's configure. I'm going to choose a profile. I'm going to choose video, which is appropriate for both Dante and Crestron NVX. I have to choose the ports that I want to add to the profile. Let's choose all ports. I haven't found a way to do a multi-select, so you have to click each port individually, give the profile a name, choose a VLAN ID and a color. Now, if you want to edit IP settings, there's a button all the way to the right. It's a bit hidden. Then you click static and enter the IP address you want to give to your new created VLAN, VLAN 10 in this case. Add a subnet mask. I'm going to choose a standard Class C subnet mask. And here is an option to activate the DHCP server from the ProAV GUI. I'm going to use the same IP address for my default router and the Google DNS as DNS server. And we're all done now. If we go to overview, we can see what we've actually done. All the ports are blue, and that's because they're all assigned to the Crestron profile we created. We can make a link aggregation. Let's say we want to connect this switch to another one through the fiber ports 13 and 14. We give the link aggregation a name, a lag ID, and we have to choose the profile, the Crestron profile we created. Click Save, and we're done. Go to Overview to check. Again, all ports assigned to the Crestron profile and ports 13 and 14 are labeled L1 because that's the lag we created. Unfortunately, there's no quick way to view the settings of a pre-configured profile. The way to do that is to apply the profile and then go to the classic web interface to check the settings or check configuration files. But there's also the possibility to create your own profiles. And from this menu, we have a pretty good idea of the settings that are present in a profile. They are multicast and IGMP settings, the precision time protocol settings, and quality of service. As an example, here is a part of a configuration file that was created when I chose the video and AES67 profile. As you can see, a VLAN is created and IGMP Plus is activated. There are quality of service settings present as well as the activation of the precision time protocol transparent clock. One of the unique features of the M4250 is NETGEAR's IGMP Plus. What is this? I will try to explain at a high level without going into too much detail. I will begin by briefly explaining IGMP and move on to IGMP Plus later. IGMP stands for Internet Group Management Protocol. It's a protocol to manage multicast traffic and it is used by all manufacturers. Simply put, on a switch level, correct IGMP configuring assures that multicast traffic is only sent to the endpoints that would like to receive it, to avoid wasted bandwidth. I will give you an example. Here we have a switch, 4 transmitters and 4 receivers. Transmitter 1 is outputting a multicast stream and receivers 1 and 4 are interested in this stream. What we want to avoid is that the stream is also sent to receivers 2 and 3 to avoid wasted bandwidth. To do that, we have to configure the switch for IGMP. This is not that complicated, but if we move on to a setup with multiple switches, things are different. With multiple switches, the IGMP configuring process is quite complicated and also vendor specific. What can we do to get around the complicated multi-switch IGMP configuring? We can activate PIM, a multicast routing protocol, and IGMP wise things are much easier now. But unfortunately the PIM protocol itself is quite difficult to configure. We can use stacking, combining multiple switches to one virtual switch. The downside is that this feature is only present on the more expensive models and that the allowed number of switches in a stack is usually limited. The third option is NETGEAR's IGMP+. It's a proprietary addition to the standard IGMP protocol that takes care of the multi-switch IGMP configuring for you. It can be activated with a single mouse click. On VLAN 1, IGMP Plus is activated by default. Although I wasn't able to test the feature, it looks like IGMP Plus will simplify multi-switch installations considerably in a multicast environment. In the audio world, Dante, audio over IP, is very popular for quite some time. I see that in the video world, Dante is gaining momentum as well. So let's try out the M4250 with Dante. So here's my simple Dante test setup. I have two laptops. On the first one I installed Dante Via. On the second one I installed Dante Virtual Sound Card. There are differences between the two Dante applications, but they both turn your laptop into a Dante device. I played an audio file on the first laptop and sent it over the network through the M4250 to the second laptop and listened to it with a program called Audacity. It's an audio recording software. The only thing lacking now is Dante Controller. Dante Controller is used to route the audio over the Dante protocol. I installed this Dante Controller on the first laptop. Dante, but also for instance AES67, make use of the precision time protocol to synchronize clocks with microsecond or even nanosecond accuracy. In our case, each laptop has its own independent clock and they are synchronized by exchanging P2P messages. Because we have a switch between the laptops, the P2P messages are going through the switch. The switch introduces a small delay. Not a problem as long as the delay is equal in both directions. That's why any switch will work. However, when the traffic load increases and the setup consists of multiple switches, the accuracy rapidly decreases with non-PTP aware switches. A PTP aware switch with a transparent clock like the M4250 will timestamp the traversal time in the PTP packets. That is, it stamps the time the packet spent inside the switch. This way the accuracy is maintained. To configure the switch for Dante, I went to the ProAV GUI and selected the Audio Dante profile. Then I added all ports to this profile except for port 12 that I used for routing. Unfortunately, the setup didn't work. When I looked inside the Dante controller, I saw that the two laptops were not synchronized, so I immediately suspected the precision time protocol. I went to the classic interface and saw that the Dante profile indeed enabled the PTP transparent clock. When I disabled the PTP transparent clock, everything worked. So what's the explanation of the Dante issue I discovered? In my setup, PTP version 1 messages are exchanged, and the M4250 blocks these PTP version 1 messages when the transparent clock is set to on, and this is confirmed by NETGEAR. So this is not supposed to happen. NETGEAR already provided a solution. They sent me a new firmware that solved the problem, but if you encounter the problem, you can always turn off transparent clock manually. So here's the Dante setup with my laptop on the left playing the VLC file with Dante Via installed, and it's streaming this to the laptop on the right. To complicate things, I also installed the Crestron NVXs, the 2 encoders and 2 decoders, so they're all running on the same NETGEAR M4250 switch. And as you can see, the audio is playing fine, but the video through the Crestron NVX is also playing fine. I also did a simple Dante routing test with exactly the same setup as before, only this time I opened some additional applications on the Dante VIA PC on the left to stream the audio to the PC on the right with Dante Virtual Sound Card. So this is the Dante controller interface where we can do the routing, but you can also see the properties of your Dante devices, our two PCs with their IP addresses, the clock status. We can see that they're both synced and that the VIA is master and the other PC is slave. It's synced to the master. Routing, again, are two PCs, but this time with the individual audio channels. Here we have all the applications, left and right channels, that I opened on the Dante VIA PC, and we can set cross points to route the audio to Audacity so we can hear the audio. I can set another cross point to a movie player that's opened on the Dante VIA PC, or some audio that is playing in Google Chrome. So now it's time for the verdict. The cons. Occasionally the web interface of the multi-gig M4250 responds slowly and the CPU load increases considerably. It's a confirmed issue with the multi-gig version only. I was sent a 1G version and that works fine. NETGEAR is working on a solution. When you try to connect to the 0conf address of the switch after a factory default reset, it takes something like 4 to 5 minutes before the switch responds. If you connect to the outer band port, it takes less than a minute. The classic DHCP server needs some work to make it more user-friendly to configure. For instance, it's difficult to bind IP addresses to MAC addresses. Another solution would be to increase the functionality of the DHCP server in the ProAV GUI. The maximum number of ports in the M4250 series is 16 on a single switch. A higher port count would be welcome. The ProAV GUI can be improved. The IP edit button all the way to the right, grayed out, is not very obvious. There are no power over Ethernet settings in the ProAV GUI. At least there weren't, because in the latest firmware this was implemented. So we can scrap that one from our list. There's no way to edit or inspect predefined profiles to see what the settings of such a profile are. The only way to find out is to apply the profile and then check it in the classic web interface or the configuration files. I haven't found a way to do a multi-select for ports. You have to click each port individually. So what do I like about the M4250? I like the fact that the classic web interface looks familiar. It's the same web interface that can be found on any other modern NETGEAR switch, even the cheapest one. The M4250 is flexible. When you look at its ports, 1G, 2.5G multi-gig, 10G, fiber, copper, PoE+, and even PoE++. There are several mounting options available. The fan of the switch can be turned off completely. The out-of-band port separates configuration traffic from AV traffic. Very convenient. There are some high-end features available, including PIM multicast routing and the precision time protocol transparent clock. The ProAV GUI is a real asset for AV system integrators because it simplifies configuration. IGMP Plus simplifies multicast configuration in a multi-switch environment. The bottom line is that it's very clear that the M4250 is designed for audiovisual use from the ground up, and it shows that the AV market is important for NETGEAR. Thank you for watching this review. If you have any comments or additions, please let me know.